Là. Welcome. So we are a grassroots organization at the University of Vienna who's trying to make research more sustainable. And we do many actions in the lab, and you can find it on our website. And we also have this lecture series we're on today, and I'm happy to introduce today's speaker, Fabrice DeClerck, who is working at EAT-Forum at the Lancet Commission. Fabrice is actually originally from Belgium, like I am, but then moved to the US very early on and spent most of his early life in the US. And he studied agriculture and environmental sciences and has applied it in many fields. And been traveling in many countries, mostly in developing countries in Latin America, Africa, and Asia. And for the last, I think, 15 years, he's been focusing on food and the impact of food. And this will also be what he will be talking about today. He always, so what interesting for us is he always took a very science approach, and also published lots of scientific journals in the renowned journals like Science and Nature, to try to really make fact-based decisions. And I think this is what he will talk about today. And the goal, and maybe Fabrice will talk about, is then to really not just look at the environment, but also combine it with human health. And just as a side fact, the last sentence on his CV I liked a lot. As an urban gardener myself, he also puts it into practice and has a garden project, and even is brewing his own beer. So Fabrice, thanks for joining us, and look forward to your talk.
My pleasure. Thanks, Jeroen. Yeah, and if we get to meet face to face, we'll be able to share a beer. But it is we did open a business in November, and it's been interesting because it's forced us to think about how do you apply a lot of these principles, circularity and sustainability within the business. Ricardo, I'm going to hand over the waiting room to you. Perfect. Thanks everyone. So first of all, a big thanks to you, Jeroen, for the invitation, and for everyone for joining. And I really think admirable that there's a specific group that's asking itself how researchers in the research community can contribute to these enormous challenges, including the climate challenge, as we'll talk about today. So what I wanted to focus on was the EAT-Lancet Commission, Healthy Diet from Sustainable Food Systems. It is work that we published in 2019 and work that will be relaunching this June at Stockholm Plus 50. So if there are any of you that are interested in the commission, and particularly if there are some young researchers who are thinking about what's next, we are looking for 5 to 10 postdocs who will join us on that adventure. So don't hesitate to drop me an email, fabrice@eatforum.org, and happy to have a chat. So let's jump right in. So the commission, first of all, I want to make sure that you understand that the commission was chaired by Johan Rockström and Walter Willits, and then supported by about 20 scientists who served as commissioners. And then with that, an additional 20 to 30 scientists who played an important support role. So this really is the collective work of about 60 researchers trying to assess how food systems would be able to address challenges of both human health and environmental health, which is what we'll focus on today. So when we started this work, and it was really Gunhild Stordalen who had married into the hotel industry and was asking, how they might be able to shift their business so that it would be contributing to both human health and environmental health. And in conversation with the Johan Rockström, I realized that there was, if you want, no universal definition of what a healthy diet was, nor, if you want, a description of what the planetary boundaries or limits to food might be. So very difficult for private sector partners or others to be able to assess what impact they were having. So that sets part of the framing. The other part of the framing, I think, is really to emphasize the planetary boundaries basis, and also this notion of Anthropocene. And maybe with you, it's less important to dive deep into this, but the main point of using an Anthropocene basis is recognizing that today we, humanity, have become a geological or planetary force on nature. We used to be able to talk about localized environmental challenges. The big tip of the Anthropocene is that we're now talking about planetary scale environmental challenges. So the decisions that we make individually as well as collectively have planetary scale impacts. The second observation behind that, and this is work that William Ripple led as part of the Scientist Warning Group, is that we're not yet bending environmental curves enough. And there's two things that I think I want to emphasize here. One, the notion of curve bending, and that is looking at major environmental trends. We see that many of them are continuing to be on rather rapid and sometimes even exponential changes, and we need to be able to bend those, or to, as you can see in the upper left, as we did with ozone, shift it from a major environmental variable to one which is now back under control. We don't talk about ozone depletion as a major environmental threat anymore. But we unfortunately don't see that same kind of pattern when we talk about freshwater resources, which continue to be in decline per capita, and with major cities such as Chennai in India, Cape Town in South Africa, Sao Paulo in Brazil, or Los Angeles, where I grew up, running into acute water shortages. 80% of fresh water consumption is for food production. Yaron, things okay or no?
Everything is okay. I think so, some of the person is not muted, but I'll try to mute her.
Nope, no problem. In the second row, you see a second set of variables, dead zones, which are areas that are polluted by nitrogen and phosphorus, 80% of which again come from food production, and about 20% from cities. We used to talk about a handful of major eutrophication events in the 1960s, and now we're experiencing more than 600 annual eutrophication events, again, mostly driven by the loss of nitrogen and phosphorus into freshwater and then into marine ecosystems. The amount of forest loss continues to decline, and with that, biodiversity loss, again, primarily driven by land conversion for food, 80% from food. And then the last row, greenhouse gas emissions, of which only 30% come from food, but a major environmental concern. So when you look at these figures, I think recognizing that food, which is our most proximate relationship to environment, has become a major source of environmental degradation. So how do we bend these curves, and what's the role of how we produce food, where we produce food, what foods we produce in bending that relationship? The second thing that we recognize is that when we look at the food and health, we're also seeing major environmental challenges, major challenges. 2 billion people globally lacking key micronutrients like iron and vitamin A, an unacceptable 155 million children who are stunted, 52 million children who are wasted. And those numbers, which had been declining for several decades, now have been on the increase over the past 3 to 4 years now, largely driven by the 3 C's, COVID, climate, and conflict. But the other thing that we see is that an equal number of individuals are struggling with accessing healthy food. 2 billion adults are overweight or obese. 41 million children are overweight, and with some countries, these values are in excess of about 40% to 50% of the population in obesity. So food, which is our primary and our first relationship with health, in many ways is largely failing over half of the world's population. So with that in mind, food now has become the primary driver of premature mortality globally. When you look at the major risk factors to health, 6 of the 11 top risk factors are related to food. So again, food, which should be a primary source of good health, has become the primary source of poor health globally. Okay. There you go. So the main objective of the EAT-Lancet Commission, published in 2019, was to see whether we would be able to achieve healthy diets for 10 billion people by 2050, and do this within environmental limits. So the two most important questions that were tackled by the Commission is, can we define what a universal healthy diet is? And I'll present those results shortly. And then second, can we define what are the environmental limits of food production? And then to do modeling work to see whether it would be biophysically possible to feed 10 billion people within environmental limits by 2050, and to propose some ways by which we could do that. I like to describe this as the planetary Oreo, not because Oreos are healthy or good for us, but because the primary basis of the Commission was defining those two hard boundaries, right? The first shell of that Oreo is, what is a healthy diet? And this is biologically determined. We as humans need approximately 2,500 calories per day. We need those calories distributed across a range of food groups. As we begin to either over or under consume, or consume primarily from one or another food group, the risk of a dietary challenge increases. There's not much that we can do about that biophysical need. We can determine it from a scientific perspective. The other hard boundary are the environmental limits, or the so-called planetary boundaries. Which have as a basis understanding that the Holocene, 10,000 years of past history, have been a period of relatively important environmental stability. It's the period in which human evolution was the most important, and it defines the safest space for continued development of humanity. So it's, again, a biophysical limit that we can assess, and we can ask ourselves then, to what extent can we begin to push those environmental parameters before it begins to have important consequences on human health and human well-being. So two hard biophysical boundaries that are difficult to modify, but which can provide guidance for development. And guidance is the soft, creamy filling in the middle. So we as society have a choice, how we travel, what energy we consume, what we eat, where we source those foods, how we produce those foods. Those are all important socio-political, socio-economic debates and opportunities. They're plastic, they're moldable, they're malleable, they're the choice space that we have. But that choice space, again, is bounded by these two biophysical limits. So big premise of this is really that while we often focus on how do we fix or resolve a solution, what technologies can we put in place that allow us to address challenges, understanding both what is a healthy diet and the environmental limits of food would help us to prevent some of the challenges that we're confronted with today. So for example, we might ask ourselves, had we been better at transitioning towards within planetary boundaries or within healthy diets, what would the impact of COVID have been today? Noting that the majority of people who have struggled with COVID are the same populations that are struggling with dietary health. So it is about seeing whether better understanding the limits allows us to prevent some of the challenges rather than simply working after cures. So let's dive into these boundaries. So the first one, well, just to provide some of the methodology, when we looked at what was a planetary health diet, we looked at three main methodologies. So it wasn't just one, but one, randomized controlled feeding studies with risk factors and outcomes. The second was observational cohort studies with long follow-up and disease outcomes, and then randomized controlled trials of diet patterns as a third outcome. So those are three ways by which we try to identify what is a healthy diet. And this is what we came up with. And it's something that any of you who've looked at national food-based dietary guidelines would probably also recognize. And it has two major elements. One is food quantity. So 2,500 kilocalories per day as being the amount of food that we would recommend as a global average for the adult population. Yes, of course, this will vary depending on whether you have a very active lifestyle or less active lifestyle and whether you're old or young. But on average, globally, this is the value that we're looking for. And then second is food quality, which is represented by the values on the right. And there's two important, I think, communication errors that we made when we presented this, which I think is also interesting from a scientific point of view. So the first communication error was that the bold orange numbers are not the important ones. What's important is the numbers in parentheses, because it indicates the range of flexibility and choice that exists within a healthy diet. I think as scientists, we're often interested in the average in order to permit our analyses, but from a human choice and a human behavior change perspective, it's the parenthetical numbers that are the most important. And then the second major communication challenge, which I'll address in a moment, is that the values here are presented in daily consumption recommendations, whereas I think that we would have preferred to communicate particularly the protein sources in weekly values, and I'll show that to you in a moment. So in terms of quality, we are looking at 30% of our calories coming from grains, primarily whole grains. Sure, rice, wheat, maize, but why not sorghum or teff or fonio or millets? But there is, again, a diversity of grains that we could be increasing consumption of. Fairly moderate consumption of tubers and starchy vegetables, potatoes and cassava. And again, here recognizing that the range is 0 to 100. The two food groups that have minimum values above 0, vegetables and fruits, 200 to 600 grams per day for vegetables, 100 to 300 grams per day for fruit. When we talk about milk, it's 0 to 500 grams per day. And then when we talk about the fats, unsaturated fats at 20 to 80 grams per day, the saturated oils at 0 to 11 or 12 grams per day, and then sugar at 0 to 30 grams per day. And sugar you can probably do without. When we look at the animal sourced proteins, I think much better present them in this way. So from a health point of view, the recommended weekly ranges of animal source food consumption, so meats, is 0 to 200 grams per week of beef, lamb, or pork. So that really is 1 to 2 servings on average. 0 to 420 grams per week of chicken and other poultry. 0 to 175 grams per week of eggs, and then 0 to 700 grams per week of fish, with a total range of 0 to 1,500 grams of animal source proteins, excluding dairy, per week. So I think the important point to emphasize here is that there is good evidence that you can be a healthy vegan and a healthy vegetarian, as well as good evidence that you can be a healthy omnivore. And so that, that flexibility is important, and it's not imposing, at least from the health side, a vegetarian, vegan, or any other diet on individuals. That choice is an important component of the recommendation. On a plate, it looks like this: about half of the plate covered with fruits and vegetables, 30% whole grains, more moderate consumption of animal source foods, greater for many of us in the West consumption of plant source proteins, and then moderate amounts of unsaturated fats. Emphasizing a huge diversity of choice. A lot of people ask me about cultural preferences. And again, I think, what we want to remind ourselves is that within those ranges, the diversity of foods available provide ample scope for people's cultural preferences. You can source Mexican or Ghanaian or Japanese or Chinese ingredients and be within those ranges. The important part, again, is making sure that you're consuming across a diversity of food groups. And then within food groups, diversity allows us for that enjoyability as well as those cultural preferences. The challenge is that when we look globally, this is not what we're eating. And particularly for those of us in the West, we're talking about a 400% overconsumption of animal source foods, and then overconsumption of many foods that are unhealthy when overconsumed. Let me move my bar here. Great. So this is work from the Global Burden of Disease Collaborative, which has done some analysis on what consumption looks like globally. I like these figures because it shows that there are regional differences that are important, but also some global trends as well. So the green line for each of these figures, and on the left is fruit consumption per day. The second one is vegetables per day. The third one is legume consumption per day. That's beans, lentils, and pulses for the French speakers. Whole grains per day is the fourth, and then nuts and seeds in the last one. What you see on this figure, and then the bars are the different regions, the dotted line is the global average. So what you see is that when we talk about fruit, vegetable, whole grain, and nut and seed consumption is nearly universal underconsumption globally. And so we talk a lot about reducing red meat consumption. We probably don't talk enough about increasing the consumption of these foods, which often are quite protective in diets. You see some variation in vegetables, particularly around Central Asia, eating the recommended amount, and then North Africa and Middle East getting close. And you also see that in terms of legumes, that there are parts of Latin America and the Caribbean and Africa that are consuming at or above the recommended levels. But other than that, for the majority of the world, major underconsumption of these foods. For those of us working in agriculture, and I spend much of my life working with the Consultative Group for National Agricultural Research, this has been a really important figure for us because we have invested very heavily in agricultural research technologies to increase the production of rice, maize, wheat, and potatoes. We don't have that same level of investment in terms of producing those foods which are currently under-consumed. So it's raised, I think, a lot of really interesting questions about whether we should be investing more in these foods. We have good evidence globally that we are producing sufficient calories to be able to feed everyone everywhere globally. So it's not a question of producing enough food today, but if we wanted to provide everyone everywhere with the healthy diets, we would find that we are underproducing, particularly fruits, nuts, vegetables, and legumes. We can look at that same figure, but looking at the foods which, when they are overconsumed, can become unhealthy. And so here we have red meat on the left, processed meat is the second one, sugar-sweetened beverages at the third, trans fat and sodium as the last two. I think what I want you to notice, particularly around red meat, the green bar again is recommended consumption. And so this is recommendation is not to exceed that value. What you find is that in many parts of the world, we are exceeding recommended consumption of red meat, particularly in the West, but there are other parts of the world, particularly in sub-Saharan Africa and parts of Asia, where we could increase consumption and it would remain healthy. Processed meat, the value is much lower, and again, overconsumption, particularly in the West. The sugar-sweetened beverages, which we don't talk a lot about from a climate point of view because the climate impact is pretty low, but the green bar is so close to the y-axis that you can hardly see it, and really massive overconsumption of sugar-sweetened beverages, including juices in most parts of the world. And this is what drives a lot of the obesity and diabetes concerns. So, the main takeaway here is that what we found when we launched the Lancet Commission is that the Western media in particular jumped on this message of reducing red meat consumption. This is an important challenge for the US, for many parts of Europe, for Australia. It may not be the primary challenge for some parts of Africa and Asia. So we need to change that messaging to reducing overconsumption of those foods as an important health challenge while recognizing where increased consumption might be helpful. The other element that I think is often not communicated enough is that if you consider diets as being constrained by 2,500 calories, the distribution of those calories across food groups becomes quite important for health. And the Global Burden of Disease used a different kind of risk analysis than we did in the Lancet. But what they show, and arriving at the same number of individuals who struggle with diet, is that it's the low consumption of the protective foods that are the primary health concerns rather than the overconsumption of red meat. But of course, the more red meat you consume, the less space there is within a 2,500 calorie diet for those foods that are protective. So diets high in sodium are the #1 cause of premature mortality attributed to diet. But then below that, it's low in whole grains, low in fruits, low in nuts and seeds, low in vegetables, low in seafood or omega-3, low in fiber. And so increasing the diversity and increasing the density of plants in our diets is as important, if not more important, than reducing red meat consumption. But of course, these are two sides of the same coin. Reducing red meat consumption, reducing starchy sugar consumption is what allows you to increase consumption of other foods within a calorie-constrained diet. Our estimate using those three methodologies is that transitions to a healthy diet would allow us to avert 11 million premature deaths per year. So this is, I think, quite important. Right now, the cost of unhealthy diets is rather enormous, and that transition would have important health benefits. What I want to maybe conclude here before we begin to move to the environment is that the evidence is that, so this analysis was done only looking at health impact. We did not ask whether this is the climate diet or the environment diet or whether it's the water diet. This is simply looking at what are the changes in diets that would allow us to improve health outcomes. We then look in the modeling work at what the impact is on environments, but it wasn't a dietary recommendation based on environment. I'm going to go quickly over the next couple of slides, and I can send you the deck so you can look at it. But what we see is that in most countries, again, dietary risk is the primary driver of disease risk. And what I want you to note is that independent of the economic status of the country in question, we're seeing very, very rapid changes in health risk. So high body mass index was #8 in China, now #5 with a 67% increase over the past 10 years. Dietary risk remains the #1 risk in China with nearly a 30% increase. A country like Austria, where you guys are, tobacco remains #1 with a 1.3% increase. But if you look at 2, 3, and 4, and 5, all of the other major risks for death and disability are food-related, with a more moderate 15% increase in diabetes, which is among some of the lower increases that we've observed, but still #3 in terms of health, death, and disability for Austria. Europe seems to be faring better than many countries. Here's the United States. High body mass index from #3 to #1 with a 22% increase, 26% increase in high fasting plasma glucose or diabetes, and then drug use, 67% increase, which was due to the opioid crisis that I think they're starting to get out of now. Countries like Mexico, #1 risk for death and disability, diabetes, high fasting plasma glucose, with a 56% increase even at #1, high body mass index #2 at 54%. And of course, these two are quite related. So this transition in diets, including many countries that we were concerned about malnutrition. You see in Mexico, malnutrition was #3 in 2007, now down to #7, 17% decrease. Many countries where we transitioned away from malnutrition, but at the same time, just really not been paying enough attention to these other dietary related risks. Let's jump to the environment side. And so the way that we speak to or address environment, the second hard shell of that Oreo cookie, is really using the planetary boundaries concept. And so we took the initial planetary boundaries and then used an allocation mechanism to ask, well, what would be the environment? What would be the planetary boundary for food. So what's the challenge that food systems are driven by? And I think that most of you are quite familiar with the planetary boundaries concept, but it's quite eloquent in that it's really fundamentally based on a global biogeochemistry. And it recognizes that there are four major Earth system components: atmosphere, biosphere, hydrosphere, and geosphere. And that when we talk about Anthropocene-based disruptions, what we're talking about is the massive movement of one of the elements, carbon, nitrogen, phosphorus, or water, from one component to the other. So climate change is a mass transfer of geosphere and biosphere carbon to the atmosphere. The nitrogen and phosphorus, the nitrogen question is really a mass transfer of atmospheric nitrogen to hydrosphere and ultimately biosphere carbon. So understanding what are the current stocks and flow rates between components and asking ourselves how human action changes both the stocks and the flow is the means by which planetary boundaries are set. When we look at food systems and carbon, we see that 30% of the greenhouse gas emissions from food will come from food, and that the majority of these come from two big sources. One is methane emissions that come from enteric fermentation and livestock, as well as rice cultivation. And the second biggest source of greenhouse gases to food comes from land clearing and land use change. So the conversion of carbon dense forest ecosystems, wetland ecosystems to more simplified agricultural ecosystems. So how we produce food and where we produce it are major determinants of greenhouse gas emissions coming from food. The other planetary boundary I want to spend a little bit of time on is biosphere. And here, what I want to emphasize is that when we speak to biosphere or biodiversity, it's less about panda bears and gorillas and giraffes and all of those fantastic critters, but recognizing that as we transition from intact ecosystems on the left of this figure towards more human modified ones, we have significant impact in changing the composition of those ecosystems, and that the impacts of that shift in composition influence global biogeochemistry, right? So the amount of carbon that's sequestered, captured, and stored in an ecosystem is very much related to the biodiversity that's present and maintained. Going from a forest ecosystem to agriculture reduces the net carbon capture and storage and increases its transmission to the atmosphere. And you find similar trends looking at other biogeochemical processes. So it's really biosphere as a stock of these nutrients, but also a biosphere as an important flux regulator of the carbon cycle, the nitrogen, phosphorus, and the hydrological cycle. So here's the same menu, if you want, hard boundary as with our menu that we have in terms of environmental impacts and environmental outcomes. And maybe with this group, I'm going to have a bit more of a success describing it. I find it's much more difficult to describe to many groups than the food-based ones. But what we found is that food production is so important that from a biogeochemical point of view, it needs to continue to have a carbon budget of about 5 gigatons of CO2 equivalent per year, which is its current emissions today. If we translate that to global implication, it means no new emissions from agriculture. And so we're talking about increasing food production for an additional 2 billion people, but without increasing emissions from agriculture. The second boundary is land systems change. Currently, about 40% of the global land surface is dedicated to food production. If we want to be able to maintain enough biosphere intactness or ecosystem intactness, we need to be talking about a zero land expansion model that leaves space for nature to sequester carbon as well as to prevent extinction losses. The third boundary is water use. Here, the allocation is 2,500 cubic kilometers per year. And this translates to maintaining 30% or more of the flow variation within basins. The Earth Commission, I think, is going to downgrade that to 20%. But when we did the EAT-Lancet, the value that we estimated was 30%. The next two are nitrogen and phosphorus. Here we've used an application rate, so 90 teragrams of nitrogen per year and 8 teragrams of phosphorus per year. Some people prefer that articulated in terms of pollution limits, so it's 1 to 2.5 milligrams of nitrogen per liter, or 50 to 100 milligrams of phosphorus per cubic meter. And finally, for biodiversity, the original articulation of the planetary boundary, as well as what we used in the Lancet Commission, was 10 extinctions per mean species year. So we're trying to stay within background extinction rates. I find that this is a really, really difficult value to communicate to policymakers and even to other scientists. What it translates into is maintaining at least 50% of the global land surface intact by ecoregion, with an additional 10% per kilometer embedded in agricultural and urban landscapes. And that 10% is shifting, is really a pretty bleak limit. There's a big push for us to increase that to about 20% per kilometer. So those are the boundaries. What happens when we then combine this with some of the food-based assumptions? Well, the first is recognizing that what foods we consume have really important impact on environmental condition. And so when we look at emissions by food group, there is much higher emissions for meat production in particular, big range. So there is ample scope for changing how we produce those meat, but much more significant emissions from the animal source foods than from the plant source foods. And we can do that not just for carbon, but across major environmental boundaries. So here you have analysis that was done by Mike Clark, looking at those food groups and their acidification potential, eutrophication potential, greenhouse gas emission potential, land use potential, and scarcity of water use. And then you can also begin to combine that with the health impacts. And what happens when you do this is you begin to see that there are certain food groups, unprocessed red meat and processed red meat, that have disproportionate impacts on environment and on human health, particularly when they are overconsumed. And then other food groups, primarily the plant-based foods, following in the lower left-hand side of the analyses, which have a positive impact on health and a much smaller environmental footprint. So this is really what leads to recognizing that transitions towards healthy diets have a simultaneous and collaborative impact on staying within health limits, stay within environmental limits. One thing I want to raise here, just as an issue again that we've unearthed as we've been presenting this work, is that one of the challenges in communicating this is that quite often it's interpreted as a food group being categorically poor for health and categorically poor for environment. And that misses two important nuances. One, that there is such a thing as healthy meat consumption, as long as you stay within the ranges. And then second, that there are opportunities in production practices that can be nature positive or regenerative. And I think this sometimes is an important nuance that's missing some of these analyses, and that makes it difficult for us in working with either farming communities or public health communities to recognize that it's not a categorical distinction, but there are some nuances in the detail. Let's wrap up by looking at just a couple of the analyses when we look at what the potential impact is towards 2050. So here, this is work that was within the commission where we looked at what were the impacts of business as usual. And here, many of the economic models suggest that as wealth increases, so including in Africa or India or China, there's a trend towards increased red meat consumption. And I just want to flag that that's an assumption of the economic models. And we're finding some evidence that this assumption may not hold as true as many of us expect. But if you transition towards a wealth-adjusted adoption of a Western diet, compared to, so looking at the 2010 population compared to 2050 population, the impact is to double the greenhouse gas emissions from food, largely driven by animal consumption. Second, we would increase cropland need by about 30%. This is distributed a bit more evenly in recognizing that staple production would need to increase. Food system freshwater use would increase by about 30%. Nitrogen application would also increase by about 30%, and phosphorus application, again, by about the 30%. If we look at this from a planetary boundary point of view, so here in this figure, what is considered to be within the safe environmental space is the green portion at the bottom of the figure. The variability space where we're not sure whether it's within or outside the limit is the yellow space, and then the red space at the top is outside of the planetary boundary. And what we find here is that business as usual, the red bar that you see for each of these categories, pushes us beyond the planetary boundary for food in nearly all cases. What we then want to understand, well, what would be the reduction potential of major food system changes and shifts? And that's what you see with the yellow, gray, green bars. Yellow is reducing food waste and loss by either half or by 75% for the light blue. The gray is improved production efficiency. And then again, 2 levels of increased impact. The green is a dietary shift, where the dark green is a more generalized adoption of healthy diet, and the light green is a more aggressive flexitarian approach, which has significantly smaller, particularly meat consumption values. And so 2 things to note is that depending on which planetary boundary we're interested in, the interventions have different impacts. So dietary shifts have a very large impact on greenhouse gas emissions in particular. Improving production efficiency has a much larger impact, particularly on land, water consumption, nitrogen, and phosphorus. So again, different impacts of different food system interventions. And the second thing to observe is that none of those interventions by themselves gets us within the safe space, but rather it's the blue bar, which is the combination of reducing food loss and waste, improving production practice, and dietary shifts towards healthy diets that is what gets us into green. So this call for much more systemic work and much more systemic understanding of those shifts really is quite critical. I'll wrap up maybe here, and then I'll skip to the end, Jeroen, to leave room for discussion. But what we found, and this is work that Mike Clark did post the Lancet Commission with David Tillman and several other colleagues, is that when you look at the reduction potential and the 1.5 or 2 degree targets of the Paris Climate Agreement, business as usual from a food point of view gets us to about a 67% chance of being under the 2 degree limit. If we can transition to plant-rich diets, we can cut that risk by about half, and there's a 50% chance of staying within the 1.5 degree limit. Healthy calories that may be a bit less aggressive on meat consumption, cut that by 2/3, so less than a more aggressive dietary shift. And then you see that the changes towards improving yield efficiency and reducing waste also have impacts big and small in diets. But it's really a transition towards being able to address across these 3 interventions that has the best chance of bringing us within a 1.5 degree target. So 50% application of a healthy diet, reducing food waste and loss, improving production practice gets us within a 67% chance of reducing food-based emissions to within a 1.5 degree limit. 100% adoption gets us well below that and transition to a net zero climate impact. I had a couple other studies that I can show, but I think, Jeroen, I'll skip them. I can go back to them if people want. But I think that, the most important take-home message here is that dietary changes from current diets to healthy diets are likely to substantially benefit human health, would allow us to avert 11 million premature deaths per year. That's a 20% reduction. And also that feeding 10 billion people a healthy diet within safe planetary boundaries is biophysically possible, right? We can't find any evidence that we would not be able to feed 10 billion people healthy diets within those rather aggressive environmental limits. So it's really much more question of political will and socioeconomic capacity to move within those limits. And if we're able to do that, I think much more promising outlook for ourselves and for our children. I'll stop there, and I think I've left enough time for questions and discussion, Jeroen.
Hi, Fabrice. Thanks a lot for all this information. So we'll do it as usual. If people want to ask questions to Fabrice, please post them in the chat and I will read them out, or Fabrice can start reading them themselves, and we'll try to answer them. So there's already one from Olivia, and she asked about what's the impact of the transport. So I guess local food versus food from Mexico or wherever you want to get your avocados from. Yeah.
Yeah, that's a great question, Olivia. So we cheated a little bit in this, and we assumed that transportation achieves carbon neutrality by 2030. I think it was by 2030 that we used, and so what we felt was important here was to analyze what was the food sector's contribution, and we allocated the transportation to the transportation sector. So there's an assumption that transportation goes to carbon neutral practices. So in today's day and age, if you're talking about transportation of fresh produce via airplane, yeah, there's significant environmental impact and climate impact that we'd be concerned with. Large-scale transportation of grains or dried goods, coffee, tea, etc., by boat really have a very, very small climate impact and do contribute to local economies in those locations. So we were less concerned about those, but certainly much bigger climate footprint when you're talking about fresh food production and transportation over large distances.
Is there a big change? Because I read something that, for example, avocados are now mostly shipped by ship by now, like bananas, that they're made ready during the shipment, where previously they were shipped by plane mostly. Yeah.
Yeah, so important changes in food storage and transportation, including I think some of these new, I forget what they're called, but there's there's polymers and waxes that are being applied to fruit, which either reduce oxidation or slow maturation. Those are interesting solutions that are being used to reduce that air freight. Yeah.
So there's another question from Evelyn, who asked, how can you compare conventional versus organic farming, where I guess it's I don't know the data, but organic farming use more land space, right? Because it's less condensed and so.
Yes, that's a great question, Evelyn, and it's one that we're in the thick of, and which we're going to put a lot of attention to in EAT-Lancet 2.0. So under today's practices, organic has a production gap, not across all foods, but across some foods, which can be in the range of 20%. I think changes and improved research to organic production practices are going to close those gaps. I think one of the things I would urge us to be careful on is blanket statements on the underyielding of organic compared to conventional, that I suspect with greater investment in agronomic research, we'll be able to close it. But more importantly, I think that when we speak to food production, and I think we're using the word regenerative agriculture more and more, it's challenging the food producing community to demonstrate that 40% of land that's allocated to agriculture can be nature positive. So can we demonstrate that in farms and on farms, we're now increasing carbon capture, that we're improving water quality, and the loss of nitrogen and phosphorus to aquatic ecosystems has been reduced. And I think that a combination of agroecology, precision agriculture, placing buffers around production systems, whether it's a riparian buffer or a hedgerow or no-mow zones around fields, all are going to be important parts of that solution. So when we speak to regenerative, I think we're trying to say, let's not try to categorize something as conventional, organic, or other, but rather let's set really clear environmental measures for agriculture, and let's challenge those communities to demonstrate how they can develop practices that improve or are nature positive, as well as reducing yield gaps. Maybe to conclude on that one just a little bit, Evelyn, I think what we often hear about the yield gap story of organic is important, but I think it masks just how much of our lands are used to produce food, which is health negative, right? So we talk about the underperformance of organic, but the amount of land that's used to produce foods that have negative health impact, whether it's sugarcane or whether it's high fat, that really is enormous, and I think more than compensates for existing yield gaps.
Yeah. So there's a follow-up question from Andrew with the question is, can this restorative farming really feed 10 billion?
Yeah. So I don't find any evidence that regenerative can't feed 10 billion people. And this is something that we're doing analysis on right now. The challenge is, when I say regenerative, what's the image that comes to your mind? Are you all thinking of a very primitive or traditional production system, or are you thinking of options that can coexist with our high yielding system? So for example, if I think of Iowa, their regenerative in my mind is going to be a system that maintains a riparian forest intact, that maybe is using more precision production practices to apply particularly the nitrogen and phosphorus, another practice to reduce contamination of water, or that is integrating, rotations that include a diversity of the crops over years, or that is combining two crops. So there's really tremendous scope for what fits under regenerative. I think when we leave room for that innovation, I personally can't find any evidence that you would not be able to have regenerative and high yielding.
Okay, there was a question from Ricardo. There's always talk about the rice and methane production. Is this really true? And then does it depend on where you produce the rice or how you produce the rice?
Yeah, great question. So rice production, this is primarily flooded rice, right? So when you flood a rice field, you convert the soil system from aerobic to anaerobic, and under the anaerobic conditions, it produces methane rather than CO2. So for rice, there's some rather simple fixes that's called alternative wetting and drying, which leaves that ground drier for a great portion of the year and reduces the methane to the CO2 balance. So there are practices for rice, particularly in either unflooded rice or by increasing the dry period, that help to account for that.
And there's a question or two questions from Sophie. When you showed the ranges for a healthy intake of different food sources, there was no range indicated for whole grain. Why is that? Or
yeah. So Walter Willits proposed this, and even got a lot of pushback from us. But the caloric intake from grains is so important to human diets that he felt that that 30% value was the critical value. And I think that in the next version we will provide a range around that, but it's going to be a much narrower range than for the other food groups.
And does water uptake by humans also count, or the daily water consumption?
No. So water is not in there, but you can drink as much water as you want. I think US EPA says 8 gallons of water becomes a health risk.
Okay, then there's another question from Shi Yung Ming. The mortality risk of high red meat consumption was shown in 2 different graphs, and their attribution to that numbers seem quite different. Could you clarify that?
Yeah, that's a great question, Yuming. So it's two different approaches that were used both by the EAT-Lancet Commission and by the Global Burden of Disease. And they really are opposite sides of the same coin. So Walter Willett and group really emphasize the negative health impacts of particularly the cholesterol and the high fat and the cardiovascular risk of red meat consumption in particular. Whereas the global burden of disease has found that using a more whole of plate approach, that it's the reduced consumption of protective foods that drives that risk. So where those two intersect is that the greater consumption of red meat in diet within a 2,500 calorie limit reduces the space with the calories available for the other plant-based products. And so there's a bit, I think, of some questions from these trials about whether it's underconsumption of the healthy foods versus the overconsumption of red meat that drives that risk.
All right, and there's a question from Sarah. Is how about plant-based foods that has less, or how about plant-based food that has more fat and sugar than the dairy component, like soy milk versus low fat milk?
Yeah,
is there then a better one or a?
Yeah, so that's okay. So that's a great question. So first of all, milk consumption is not a health threat. There's no evidence. Well, I mean, between up to 500 grams per day, which is a lot of milk. That becomes smaller if you're looking at cheese because you're looking at the original content of milk. So small or moderate cheese consumption, again, can be healthy. For those who are choosing not to consume milk and dairy products for whatever reason, but environmental reasons, you have a smaller environmental footprint by shifting to plant-based products. But the question is quite right from, I forget who asked it.
Sorry, yeah.
Yeah, sorry, is that many of the novel foods that are emerging on the market, and there was a Nature Food article just yesterday, do have better environmental performance, lower footprints, but do not have better health performance, right? And are being classified as processed or ultra processed foods. So the more that you either increase the additives into food, or the more you reduce the matrix of a food, so again, whole grain to refined grain, the lower its health value. And so novel foods that either are high in additives or are highly transformed, I would suspect are going to have negative or moderate health outcomes. And that's something we will be covering in EAT-Lancet 2.0. Plant-based foods, whether if you're eating a quinoa patty with red beets and carrots, where you recognize the ingredient list and the processing is restricted to chopping and mixing, are going to be both high on the health and environment side. But do keep an eye on the additives in the novel foods that are coming out. High sugar, high salt, high fat in a replacement food may reduce environmental impact, but are probably going to increase negative health impacts.
Yeah, I have maybe one final technical question. So you say that we can make food in like environmental boundaries, but if I got it right, I think like 60% of the food we eat or the vegetables we eat are dependent on nitrogen from from the Haber-Bosch process. So it's like artificial nitrogen added to the system. So if we have to really reduce like the nitrogen, which is just produced by energy in principle, we need a big change, right? Or
yeah. So there's several opportunities there, right? So the energy required to produce nitrogen is a really important question, Jeroen. So improved nitrogen use efficiency. So the precision agriculture techniques are interesting there, both in their capacity to use less nitrogen and also to reduce the losses. One of the food groups which needs to increase absolutely is legumes, so lentils, beans, and pulses. So greater rotations or integration of legumes, which are naturally nitrogen fixing, is another important opportunity. And then there's going to be the techno fixes in reducing the energetic costs of producing artificial nitrogen. But it is, as you point, very energy intensive.
All right, super. So thanks a lot. I see no more questions. So thanks, Fabrice, for joining us, and also the people in the audience. Really enjoyed it. We will take a break with our seminar series till September or October. So people who want to reach out, feel free to look at our website at the Max Perutz, and also on our website, most of our projects are listed. So if you want to know more about what we do, join us. And for future reference, this talk will also be put on our YouTube channel. So if you want to share it afterwards, feel free to share it. Thanks, Fabrice, and thanks everybody.
My pleasure, and thanks to all of you for all the work you're doing, and Jeroen, thanks for your leadership and getting us together. It's been a lot of fun.
Super. Thanks a lot.